4.2, trigonometric functions working off the unit circle. Okay, some of what we go over here will seem pretty easy because of that extra bit we did about the unit circle. Some of it will reinforce what we said, and some of it is kind of different. And remember, I did that extra piece so that anytime we start talking about the unit circle, it makes a little more sense. Okay, so this first chart you see about the definitions of the trig functions in terms of a unit circle, this should not look strange to you because we actually talked about this in our in-between notes, right? So what we start with is a triangle coming off that origin, right? And we have this theta angle, and it's always a right triangle coming off the x-axis. Always important to know that. So our unit circle always has that radius of 1, which is always our hypotenuse. We always go across x, and we go up and down y. Okay, so if you remember this chart, we put it in our between notes where sine is always the value of y, cosine is the value of x, tangent is sine over cosine or opposite over adjacent, and you get the y over x. And our cosecant, our secant, and our cotangent are the reciprocals of those. Because sine and cosine are y and x, they always have to have a value. They cannot be 0. So we don't have to worry about those ever. But tangent, cosecant, secant, and cotangent, and especially if you think back of your big chart, there are times that you do get a 0 on the bottom, and then you get that undefined term. Okay, so keep that in mind. That does happen. That's why you see a bunch of x equals and y, or x does not equal or y does not equal 0 for those, okay? So remember, if they do equal 0, you end up with no cosecant, secant, cotangent, or tangent. You just have an undefined term. Okay, so one of the key things I need to talk about here is, and we've talked about this before, the unit circle has a radius of 1. That is the definition of the unit circle. We have our unit circle chart that we have exact values. But remember, there are infinite number of ordered pairs around a unit circle. So on our first example here, we're on the unit circle. We have a radius of 1, okay? And that's important to remember. So we're on the unit circle, and our radius is 1. Beyond that, that's all the word unit circle means, radius of 1, okay? So you'll notice here that we have this value down here, this ordered pair of p, which is -5/13 and -12/13, okay? It's a point on the unit circle, but it's not one of them on our big unit circle. But when we have a value on the unit circle, we can use our rules above to find the sine, cosine, and tangent, then the cosecant, secant, and cotangent. So the sine of this angle t, okay, is simply, remember this, the y value, right? So look at your y value. What is the y value there? -12/13, okay? My cosine of my angle is simply my x value. What's the x value? -5/13. My tangent of my angle, okay, remember that's sine over cosine or y over x, okay? So I get this -12/13 over -5/13, okay? Remember, if we do a keep, change, flip, like -12/13 times 13/-5, my 13s cancel, and I'm left, and my negatives cancel, and I'm left with 12/5, okay? Just a hint here, if you start noticing this, when they have a common denominator, you can just drop it, right? And then simplify what's left. All right. I don't know why, I'm going to be honest. When you look at their list up there, they put cosecant next, maybe because it's, no, that should come next. Never mind. Just ignore my ramblings. Cosecant is my sign flipped. So if I had -12/13, I have -13/12. Remember, the negative is just attached there. It doesn't matter if it's in the top, in the bottom, or just out front. Cosine is -5/13, so that means my secant is going to just be the flip, 13 and 5, and there's a negative on there. And then my cotangent, again, is simply my tangent flipped. Since I have 12/5, it becomes 5/12, okay? So I get these values without using anything from the core unit circle that we do, but using the idea that the radius is 1. As long as the radius is 1, these ratios of the y, the x, the y over x, and all of those are true, okay? So that's what I'm looking for when I ask for the values, all the trig funds. There's 6 of them, right? I need to make sure I know where my final answers are here. Okay. All right. So far, so good? It goes back to what we used before on our chart, but we are allowed to use other values beyond our 30s, 60s, 45s, 90s type of thing. All right. Let's come down and talk about domain and range of sine and cosine functions. Okay. If we can kind of wrap our head around these. And it's going to come more into play when we graph our sine and cosine curves, okay? So sine and cosine are coming off the unit circle. Okay? The domain is your x values, your angles, your radians in degrees, either one, okay? That's what you're plugging in. So because of that, we can use anything we want, and our domain is negative infinity to infinity. Okay, if someone says, well, I want to plug in 7, we can plug in 7. It doesn't have to be 7 degrees. It can be 7. Remember, any number without a marking on it is radians, and that's fine, okay? So you can really plug in anything for your domain. Okay, the range is what do we get out of these? When we think about our sines, our cosines, and our tangents, okay? Think about the values on that big chart. What was the absolute lowest value in your sine or your cosines? I shouldn't put tangents in there because that didn't count. Sine and cosine is all we're talking about here. The smallest value, or your smallest, for sine, your smallest y value was -1. If you run radical 3 over 2 in your calculator, it's less than 1. Okay, just kind of a note there, because radical 2 over 2, that decimal's less than 1. What's your highest value for either the cosine or sine? It was +1. So our range here is going to be -1 over 1, -1 to 1, and it includes those, right? The set of all the real numbers. Okay, so that's the domain and range. And again, it's going to sink in a little bit more when we graph those next week, okay? All right, even and odd functions. Remember, we test even and odd functions when we plug in a negative value. Okay, so I've struggled. When I first taught this, I was like, I know the rule, but I can't figure out how to explain it. I think I can explain a little better now. Let's see if it makes sense. So a quick reminder for you, okay? When we talked about in a quadrant, the sine, cosine, and tangent in the first quadrant are all plus, okay? In the fourth quadrant, the sine is negative, the cosine is still positive, and the tangent is negative. Ignore what I wrote and just listen to what I said. All right. Does that make sense so far, what I'm talking about there? Okay. So, and even and odd, to test something, you plug in the negatives, right? And you go from there. So, what they're saying is, let's say, I need to put values to this because I think it makes a little more sense. Let's say I am going to use the value pi over 4. That's 45 degrees, right? If I say I want the sine of pi over 4 up here, it's going to be like positive radical 2 over 2. If I do the sine of, oops, I thought it was on a pen. Let me erase. Okay, the sine of pi over 4 is radical 2 over 2. If I do the sine and I plug in negative pi over 4, okay, so now I'm down, we talked about going negatives, go into the fourth quadrant and go clockwise. So now I'm down into this fourth quadrant. My sign would be negative radical 2 over 2, okay? So I get radical 2 over 2 in the first quadrant, but I get negative radical 2 over 2 in the fourth quadrant. It changed values, okay? And remember, if you change signs, it's an odd function, okay? So let's take the same thing, let's talk cosine. Cosine of pi over 4 is radical 2 over 2. Cosine of negative pi over 4, which means I'm going down into this fourth quadrant again. Well, it doesn't matter. Cosine's still positive there, so I still get radical 2 over 2. I get the same value, okay? So my sign didn't change here. And if you remember back on your even and odds, when the signs change, it's an odd function. When the signs do not change, it's an even function, okay? If we check our tangents, the tangent of pi over 4, well, that's 1. But if I go into the fourth quadrant for the tangent of negative pi over 4, it's -1 because tangents are always negative in the fourth quadrant. So by testing my three values of sine, cosine, tangent, and simultaneously, I think that's the word I'm looking for. Obviously with sine, we'll go cosecant, and with cosine, we'll go secant, and with tangent, we'll go cotangent, because those are just reciprocals, so their signs of positives and negatives stay the same. Because of that, we get this rule. Cosine functions, along with secant, are even, because the sign didn't change, okay? My positive stayed positive. My negative, we didn't do a negative. For sine and tangent, when I plugged in the negative value, I get the opposite value. So because of that, sine and cosine and tangents are odd. Okay? I hope that explanation makes sense, but here's the key thing to help you for the rest of pre-calc. Remember, cosine's the only even one. Just remember, cosine is even, sine and tangent are odd. Cosine is even, sine and tangent are odd. Just remember, cosine is even, sine and tangent are odd. Okay? As long as you remember that, it will help you through these problems. So, if you remember these rules, basically what you want to be able to do is if I see something like A where it says the cosine of negative pi over 6, I can ignore the negative because cosine is even, and I can just do the cosine of pi over 6, okay? And if you think of pi over 6, this is where the unit circle comes in. Pi over 6 is my first one. My cosine is my x value, and my x value there is radical 3 over 2, so my answer is radical 3 over 2, okay? Now, when I get to the next one where it says the sine of negative 3 pi over 4, I know that sine is odd. So that means this negative needs to come out front. So it's going to be negative sine of 3 pi over 4. And now I can go to my unit circle to 3 pi over 4. Okay? Well, 3 pi over 4, that is in my second quadrant, right? Yeah, because it's less than 1. So it's in my second quadrant. And anything pi over 4 has a radical 2 over 2 for its value for sine. And sine in my second quadrant is positive, okay? And then I have this negative hanging on the outside, so my final answer is negative radical 2 over 2 because of that sign. So what this even and odd allows you to do is not worry about going clockwise or counterclockwise, but always work on the clockwise because that's the unit circle that's in our brain that we can understand the best. And it puts us on our, I don't want to say first quadrant because obviously this one was in the second quadrant, but it kind of relates us to that, okay? All right, the last one, tangent. Well, I know tangent again is odd, which means my negative can come out front, and I'm going to find the tangent of 5 pi over 3. Okay, 5 pi over 3, that's more than 1. So 5 pi over 3, that lands me in the, yeah, that one, right? It lands me in the fourth quadrant. Okay, anything pi over 3, if I check my chart, right, anything with pi over 3 has a tangent of radical 3. Because I'm in the fourth quadrant, it's negative radical 3. And because I have this negative out front, my negatives cancel, and my final answer is radical 3. Okay, so that's using my even and odd idea, okay? All right, next page. Reciprocals. This shouldn't be anything different, right? So it's saying that if you find the sine and the cosine tangent, and cosecant is just the value flipped, or under 1, secant is the flip, cotangent is the flip. Okay, I need to stress this to you, because this is sometimes confused. This little value here, the t, the angle is not the reciprocal. The value that you get from taking the sine, tangent, or cosine is what we take the reciprocal of, okay? The angle is not a reciprocal, okay? So when I see A here, and I see that it says cosecant of 5 pi over 3, I'm not flipping that and making it 3 over 5 pi. That is not what I'm taking the reciprocal of. Okay, what I need to do is when I see cosecant, okay, what I'm going to do is think sine of 5 pi over 3, okay? These are my thought bubbles, okay? This is my thought bubble. That's what I'm thinking in my brain. Sine of 5 pi over 3. So this is where I'm going to tell you when we do these things, when you're doing most of this homework, have your unit circle sitting right there in front of you, okay? Recreate it if you need to, but have it out there. So I go to 5 pi over 3. I'm in the fourth quadrant. So right away I'm going to write down, well, in the fourth quadrant my sign is negative. Anything with pi over 3 has a sign of radical 3 over 2. Okay, so that's what that equals, right? Now, for cosecant, though, I need to flip it. And I'm going to actually, forgot and used up like all my space. Okay, so for cosecant, this is where I take the reciprocal. Okay, so for cosecant, we're going to flip. So I get 2 over radical 3. I can't leave a radical in the denominator, so I rationalize it. And I get negative 2 radical 3 over 3. If you need me to rationalize, let me know, but hopefully I can just do that in my head. Okay? So I think the sine of the value of the angle. I do not do the reciprocal of the angle. I find the value of the sine of it, and then I do the reciprocal of that value, and that's where my flip comes in at. Okay? Okay, so let's try it again. So when I see secant, I need to think cosine, right? By the way, guys, how do I remember which one goes together? Don't ever put the s's together. Don't ever put the c's together, right? So sine needs to go with the other c, which is cosecant, and cosine, which starts with the c, needs to go with the s, which is secant. Okay, so I'm thinking, right? That's what I'm thinking is cosine of 11 pi over 6. So 11 pi over 6. Well, that's the fourth quadrant. My cosine is positive. I go to my pi over 6's. The cosines are always radical 3 over 2, right? And for secant, I'm going to do a flip. So again, this looks like the same thing from before. I know when I flip this, I'm going to get 2 radical 3 over 3. Okay, so my last one here. I am finding the cotangent of 3 pi over 4. So cotangent I know is the reciprocal of tangent, so I'm going to think tangent of 3 pi over 4. Okay, and my cotangent or tangent of 3 pi over 4. Well, 3 pi over 4, that is the second quadrant, so it's going to be negative. And then anything pi over 4 has a tangent of 1. All right? I'm going to, for cotangent, I'm going to flip it. Well, guess what the flip of negative 1 is? Negative 1, right? So it doesn't do much there, okay? But that's how you want to handle your cosecants, your secants, and your cotangent, is think their reciprocal and then take that reciprocal, okay? All right. Sometimes I don't even like that this is where it is, but it is. Okay, quotient identities. Tangent is sine over cosine. We've already been using that over and over and over, so that's nothing new. So obviously then cotangent is the flip cosine over sine, okay? When we get to chapter 5, that's part of the first 1 or 2 questions on the test, okay? I'm just throwing it out there. You just need to remember that tangent is sine over cosine, and therefore cotangent is cosine over sine. We will use it. This second box here, okay, Pythagorean identities. Again, we are going to use these tremendously when we are working in chapter 5. We will see them occasionally here in chapter 4, but that's where they introduce them. And you do need to know these. These 3 identities you need to memorize, okay? I'm going to talk about them more in chapter 5, and we're going to talk about how to get these, but you just need to memorize them. To be honest, right now, the key one you need to memorize is sine squared t plus cosine squared t equals 1, okay? And then there's the other 2 as well. I'll talk more in chapter 5 how we come up with those 2 and how you can remember just the 1 and go from there. But always remember sine squared of an angle plus cosine squared of an angle equals 1. It's an identity. When you know that, you can do all kinds of things, change them, manipulate them to use that, okay? So remember that identity. I'm going to do one here, an example here, but to be honest, we'll use it a lot more in chapter 5, okay? So it says use the Pythagorean identity to find the cosine of t. Okay, so all they gave me was the sine of t, and that is all. Okay, so I'm thinking sine squared, okay, t plus cosine squared t equals 1. Well, I know my sine is radical 21 over 5, and I can square that. But the problem is I don't know my cosine squared, okay? So what I can do here is the math, right? I can figure out what cosine squared t is. Okay, so square root of 21 squared is 21. Square root of 5, or there's no square root, I'm sorry, 5 squared is 25. I'm trying to get my cosine by itself. So I'm going to take 1 and I'm going to subtract 25 over, or 21 over 5. So cosine squared t equals 1 minus 21 over 25. Well, to subtract them, I need a common denominator, right? Like 25. And this will become 25 over 25 minus 21 over 25. So I get cosine squared t equals 4 over 25. I'm looking for cosine t. I have cosine squared t, so it's squared. How do I get rid of square? I take the square root. So it looks like my cosine t is going to be 2 over 5. Okay? Makes sense? That's how I use my identity. Now, I'm going to do a quick little side thing, okay? You're given the sine of something. Draw a triangle, okay? And hopefully it looks a little bit more like a right triangle than that one did. Okay, remember, it always comes off the x-axis. If this is my angle t right there, sine is opposite over hypotenuse, right? So opposite my t is the square root of 21. My hypotenuse must be 5. How do I find the missing side of that triangle? Well, Mr. Pythagoras didn't only give us the Pythagorean identity, he also gave us a squared plus b squared equals c squared, right? C is my hypotenuse, which means I have to put my 5 in there. I'm going to plug in square root of 21 for my A. All right, square root of 21 squared is 21. 5 squared is 25. Subtract 21, I get b squared equals 4. Divide by, or take the square root. Sorry about saying that, and I get b equals 2. So my side is 2. Cosine is adjacent over hypotenuse. If I went to my angle t right there and went adjacent, I'd get 2 over 5. Aha, matches what I got over here. So, 2 ways, okay, to kind of figure that out. All right, let me see if I can explain periodic properties without waving my hands at you, which, here's the thing, I am waving my hands at you. You just can't see it, okay? The unit circle, it's a circle, 360 degrees. But we talked about we can do more than 360 degrees. We can keep going back. We can just roll right around that circle over and over and over. The great thing about the unit circle is it's limited to that circle of values as far as your ordered pairs, as far as your sine, cosines, and tangents and stuff. So if something is larger than 360, or something is larger than 2 pi, you can subtract 2 pi or something, okay? We call it a periodic because periodic means it repeats every period, okay? It keeps repeating each period. So if we do anything and oops, I thought I had my highlighter on. Basically, it's saying I have a value on my unit circle and I can add a full circle to it at any time, okay? And then it means the sine and cosine values, remember how we talked about knowing the unit circle's values. If we know all the unit circle's values, it doesn't matter if we went around the circle 4 times or we went around the circle 1 time and landed in the same spot, they're going to have the same values, okay? And if you think about it, on sine and cosine, we have to go all the way around the circle again so that it has the same values. For tangent, you only have to go around the circle half, and you get the same one because, just kind of think about this. Your tangent in the first quadrant is positive. In the second quadrant is negative. In the third quadrant is positive. And in the fourth quadrant is negative. So because of that, tangent only has to go halfway around the circle to get the same values again. So the periodic tendency of a tangent is every pi, or halfway around the circle. But sine and cosine, because they have their negatives come up in, like cosine's negative in the second quadrant, and then sine's negative in the fourth quadrant, you have to go full around the circle before you can say the values start repeating themselves again. Okay, they have to do a full 360, where tangent can repeat at 180. Okay? So When I look at A and B here and it says find the exact value of each trig function, do not use a calculator. The key is figuring out how far around the circle am I, okay? Or how many times did I go around the circle and where did I land once I finished my circle? So when I see cosecant of 9 pi over 4, well, 9 pi over 4 is bigger than 2 pi. So what do? I subtract 2 pi. Okay, think about like those coterminal angles we did back in 4.1. That's kind of what we're doing here. Well, once again, I don't like subtracting 2 pi because this one's in a fraction form. So if I have 4 as my denominator, I want to make it like 8 pi over 4. Okay, so same idea. Subtract that. I get now the cosecant of pi over 4. I'm going to get the same value. I just don't have to worry about going around the circle first and just sticking it to pi, cosecant of pi over 4. Well, I'm thinking cosecant, and I don't do cosecant. I do its reciprocal, which is sine of pi over 4. So this is what I'm thinking, right? That's in my thought bubble. Sine of pi over 4, it's first quadrant. It has a positive value. It's radical 2 over 2. I need to flip it because I'm finding the secant. And when I flip it, I get 2 over radical 2, which will simplify to radical 2. Remember that one, radical 2 over 2 is already rationalized. So when you flip it, it kind of unrationalizes. That's all I need to do, okay? When I look at B over here, it says the sine of negative pi over 4 minus 2,000 pi. Okay, why minus 2,000 pi? Well, that means I'm going clockwise around my unit circle 1,000 times. Does it affect any of my values? No. I'm going to be honest, as long as the sine or cosine has an even value of pi, get rid of it. It's not going to do a thing. Okay, so I'm really only worried about the sine of negative pi over 4. So from the page before here, remember that negatives on the signs do matter because signs are odd. So I'm going to pull that negative out front, and I'm going to do the negative sine of pi over 4. All right, I'm in my first quadrant. What's the sine of pi over 4? That's radical 2 over 2. When I look at my unit circle, I bring this negative out front, and I get a final answer of negative radical 2 over 2. Okay? All right, last one. Maybe trying to prove a point more than anything here, the periodic moment. As long as sine or cosine are in increments of 2 pi, it doesn't matter. So on this first one, I don't care about this minus 2 pi because sine is, repeats every 2 pi. My negative does matter on a sine because sine is odd, so I get negative sine of t. All right, on to my second term here, cosine of t minus 4 pi. Inside that t, whatever that angle is, minus 4 pi, well, to be honest, minus 4 pi means I went clockwise around the circle 2 more times. It doesn't matter, okay? And there's a minus out front, but nothing else, so it's just minus cosine t. All right, with tangent, remember, tangent only has to go halfway around the circle, and it has the exact same value. So because of that, it doesn't have to be even increments. It can be just any increment of pi, and I can cancel it. And now I'm saying negative tangent of negative t. Well, tangent is odd, so that negative of that t has to come out, and I get negative tangent of t. My minus negative becomes plus, and I end up with negative sine t minus cosine t plus tangent t. I don't know what t is. I can't do anything more, but I've at least simplified that equation down as much as I can using my rules of even and odd functions and the periodic functions. Okay? All right, practice. Page 486 to 487, 3 through 87 by 3s. Practice. The more you practice, the easier this will get.